Okay. Now, similarly, the next problem is this one. Now, find the limit of this. Now, there are two ways actually to solve this one. Okay. So, one is via integration and another one is directly. So, that directly is also already fine, but I will give you the both alternate proofs. Okay. Because sometimes you may not be lucky to have this easiest one. Okay. So, first of all again, so what is my term? So, note that it is given that limit n tends to infinity summation k equal to 1 to n. Now, you can forcefully always take 1 by n. So, this is the main idea. So, you have to forcefully take 1 by n and then you will have root n and here you have 2k plus root over 2k plus 2. Okay. Now, again that will be 1 by first of all root 2, because that from here and here you can take that root 2 outside, then it will be limit n tends to infinity summation k equal to 1 by n. Okay. And then we have root over k by n plus root over k plus 1 by n, this one. Now, again you have to understand that what is the Riemann integration, right. Now, again if we take f x equal to 1 by say root x. So, what actually the claim? So, this part is, you can replace this part by x and also this part by x, right, by the similar as the previous term, right. So, you can choose your T I in such a way that you can have this is your x, and similarly this one, that k plus 1 by n, it is not in that interval, but it is T I plus 1, that is not in that interval, but T I plus 1 is in that x I comma x I plus 1, that is the next interval of that one, right. So, therefore, there is no harm if you put x there as well. Okay. So, therefore, you will have actually the function is root x plus root x. So, therefore, taking that n tends to infinity, you have 1 by root 2 integration 0 to 1 dx by root x plus root x. Okay. So, therefore, it is 1 by 2 root 2 integration 0 to 1 x to the power minus half dx. Okay. Now, if you calculate this one, then you will get 1 by 2 root 2 into 2. So, the answer is 1 by root 2. Now, this has another trivial approach. So, first of all you can check that there is a same difference. So, therefore, you can just multiply that above and upper side and lower side by root 4 minus root 2. So, there is another alternate solution. So, what you can take? Limit n tends to infinity 1 by root n, then if you multiply the upper side by root 4 minus root 2 and the lower side as well, then you will get root 4 square minus root 2 square, right. So, you have 2, and similarly we have root 6 minus root 4 by 2 and this way 2n plus 2 minus 2n, right, by 2. this. It is because of you have same difference between this one, that inside of that, right. So, therefore, you have, oh, there is 1 by root n, sorry. So, therefore, you have limit n tends to infinity 1 by 2 root n, and this will be cancelled out with this will be cancelled out with this one, that will be cancelled out with this one. So, we will have root over 2n plus 2 minus root 2. Okay. Now, that will be limit n tends to infinity 1 by 2, then root over 2 plus 2 by n minus root 2 by n. So, this one. So, you have half into root 2. So, you will have 1 by root 2. Okay. So, this is the alternate approach as well, but sometimes you may not be lucky enough to get this kind of manipulation, right. So, better to understand that you can solve this problem via Riemann integration as well. Okay. Someone asked why 1 by n vanishes in the second step from first. 1 by n vanishes because we have taken that n tends to infinity, right. So, therefore, 1 by n equal to 0. You are asking here only, right. So, we are taking n tends to infinity. Okay. And someone asked that how did you get secant root x. So, as I told you, this is how do you get that one, that is fx. So, you need f of ti, right, and you can replace that ti by x. Now, since that k by n and that k plus 1 by n both are very close to each other, so there is no harm when you are taking that approximation, because ultimately your interval are getting closer to closer as you take n tends to infinity. So, therefore, this and this term will be very close to each other. So, you can take both of them as f of some number f of ti. So, therefore, you will get root x. Okay. So, that means here you can write almost in this way that your x will be here approximated by k by n or k plus 1 by n, that one. So, generally that is the idea. We will replace, here you can see that in the first proof, right, where I have written that, okay, this one. So, you have k by n and you replace that k by n by x, right. Okay. So, any doubt, any? So, there is another one, square root n. What do you mean by square root n? I did not use anything. In the which line you are talking about? Your doubt is not clear. Okay. Anyway, so I move to the next problem. Now, this is this. So, define f on the closed interval 0 1. Okay. Someone is written again. So, in the function f(x), square root n is not there. No, when you have f(x), there should not be any n, right. This is what? So, what was the function actually here? You can write this is as in this way. See, now you have taken that 1 by n and you have root n, right. Now, when you divide by this root n, then you will get k by n, and that k by n will be replaced by x, or k plus 1 will be replaced by x, similar as there, and the distance, that norm of p n, that will be your 1 by n. Okay. So, there should not be any n. So, that is the reason we are applying that Riemann integration. Okay. Now, this is another function. Now, it is given that f(x) equal to x square when x is rational and x cube when x is irrational. Now, there are a few options. So, f is Riemann integrable, f is not Riemann integrable, f is Riemann integrable and the value is this, and the lower sum is 1 by 4, upper sum, no, not upper sum, lower integral is 1 by 4 and upper integral is 1 by 3. Now, can you give the answer, quick answer of this one? Any quick answer? Just write in that chat box. A, D, right, good. So, first of all, so anyway, so many people can solve this easily, but again, so I should solve in a mathematical way, right? So, first of all, note that on the open interval 0 1, you always have x cube less than x square. Okay. Now, let P n is that partition, that is 0, 1 by n, 2 by n in this way. Okay. Now, what is my u f of P n in this case? That will be summation k equal to 0 to n, right. What will be my capital M I and x I minus x I minus x I minus 1. So, in this case capital M I will be that x square, right, because that is the bigger one. So, we will get summation n equal to 1 to n k by n, k by n or k minus 1 by n, which is will be bigger in this case, I think k by n, right, sorry, right. So, k by n whole square and the difference is 1 by n. Okay. Now, anyway, now taking that n tends to infinity, you can always find that. So, here that upper integral f, that will be your limit norm P n tends to 0 u P n f, right, and that is same as the normal integral, that is Riemann integration of f of x equal to x square, and that is 1 by 3. And if you take L f P n, then that sum will be k equal to 1 to n small m I x I minus x I minus 1 equal to, by similar approach you will get 1 to n, it is k by n cube 1 by n, and again taking n tends to infinity, you get that lower integral 0 to 1 f equal to limit norm P n tends to 0 L P n f, and since we know the value here, so it is just 0 to 1 x cube. So, that is 1 by 4. So, we are done. So, it is not Riemann integrable and this is the value. Okay. Is it fine with everyone? Okay, just say yes so that I can move to the next problem.
Yes, sir.
Okay. Now, this is the next one. Now, it says f be a differentiable function and f dash is bounded and P is just a partition of A B, and then you have these are the options. So, here I have included the options E as well, because I feel that this option is also interesting one. Okay. Now, can you have a quick answer of this? Yes. Okay, so first we start. So what can we do with this Riemann integrable? Okay, so if we take UPF minus integration a to bf, this one, so that will be less than equal to UPF minus LPF. Is that clear? Because that LPF is less than equal to integration a to bf less than equal to UPF. Okay, fine. Now what is my UPF minus LPF in terms of differentiability? So we know, just put the definition of UPF and LPF, then we will get summation I equal to 1 to n capital Mi minus small mi and xi minus xi minus 1. So this one. Okay. Now what is capital Mi? Capital Mi is the supremum value, right? So there should be a point, some point, say f xi some number. Okay, and also supremum, that infimum should be attained, right, in that interval. Therefore it should be some f of xi double dash kind of thing. So this is just number, right? So therefore we can write this is as summation I equal to 0 to n f of xi dash minus f of xi double dash and then xi minus 1. Okay. Now since this is the supremum value and this is the infimum value, instead of bracket we can use that modulus value. That is fine, right? That because that is a always positive number. Now you can use the mean value theorem. So what mean value theorem says? So f of b minus f of a is some f dash c, that is if you take b minus a, this one. Now if you don't know that which is bigger between a and b, then you can just pose that f of a minus f of b equal to some f dash c modulus a minus b. You can just say that, right? So this will be, so this term will be same as, so f dash some xi star, okay, and we can put modulus value and we can take xi dash minus xi double dash, that modulus value of this. Is that clear up to this? Yes, just say yes so that I can move to the next part. Okay, good. And then we actually have this one. So UPF minus LPF. So we are calculating that one, right? So that one still it is equal to summation I equal to 1 to n mod of f dash some xi star, we don't know which xi star it is, and modulus xi dash minus xi double dash, even we don't know which is the bigger one, and we have xi minus xi minus 1 this. But we always know that this one, that xi dash and xi double dash both are between the closed interval xi minus 1 comma xi, right? So that modulus value will be less than equal to xi minus xi minus 1, and this one, that is that derivative, you can choose that is less than equal to m, where now let just m equal to supremum of f dash x. Okay, then we have UPF minus LPF less than equal to summation I equal to 1 to n m xi minus xi minus 1 whole square. Okay, is that clear? Now, which is same as m summation I equal to 1 to n xi minus x minus 1 whole square, but we know that summation, say in this way, say a plus b whole square, sorry, that summation a square is less than equal to that. We know that, right? Here all the terms are also positive. So, therefore, we get less than equal to m summation I equal to 1 to n xi minus xi minus 1 dat whole square, because here all the terms are positive, right? Now, that is m. Now, if you add this value, you will get b minus a whole square. So, therefore, you get, which was the this one, UPF, right? So, u this minus integration a to b, which is less than equal to UPF minus L, sorry, FP. I always miss that one. That okay. Anyway, so less than equal to supremum of that mod of f dash x b minus a whole square. So, that means you get C here. And similarly, if that UPF, if you are asked that it is replaced by LPF, then also you could solve this problem in similar way. So, that means if you had that LFP instead of UPFP here in the option C, then also it would be a right answer. Okay. Now, is that part clear? Yes or no?
Yes, sir.
Okay, good. Now, this is one answer. Now, what about the other? Oops, I had another page. Okay. Now, what about the other parts? A, B, D, E?
Sir, A may be correct.
Exactly, but this is actually correct, A. Now, this one, it is very easy to see by in terms of picture, because what is that? So, it is given the difference between, see, just compare with UPF minus that integral value, okay? That means it is just the error. And what is b minus a? Supremum of that one, mod of fx. Now, you have to remember that here the values of mod of fx, because we are taking that upper part and lower part as well. Now, first of all, suppose you have a function which is totally in the upper place there above the x axis, okay? Then what is my this one? See, now you can have any partition, right? Now, what is my UPF minus this integral? So, that will be only this error, right? And what is that right part? That is b minus a into supremum of that value. The right side is the bigger one. So, you have to take these both value and this is the large integral, this one. right? So therefore, if you have the curve which is above the x axis, then you are done. So that's mean this is equal, greater equal to, right, because that is the actually higher value, because here you are left side you are calculating only the error part, but in the right hand side you are calculating the huge part. Okay. Now suppose you have some portion which is in the left side. So this type of curve. Okay. Then also suppose this is your partition, then also here UPF is actually looks like of LPF. That means you are calculating this kind of error. If you have this. Okay. So that's mean here UPF minus LPF will be this error. So this or this. Okay. But in that region you are taking see mod value, right. So that's mean this will be in the curve side will be actually in the upper place, this one, and this one, and you are taking that value only, that larger integral. So that is your right hand side, this rectangle. So therefore right hand side is always bigger equal to. So did you get this point? So therefore you always have that A.
Sir, by this graphical method, can we do the part C?
I do not know actually, because there is supremum of f dash. So how to tackle with that f dash? So by the graphical method you can tackle that f, right? So what is the supremum of
Yes,
f?
sir.
But since it is a f dash, so it is little bit difficult. There may be a possibility, but I do not know.
Yes, sir.
Okay, is that part clear that A is also right? Because in the left side this is just the error term, and the right side it is a big rectangle. Okay.
Clear, sir.
Yeah. And now can you just quickly rule out B and D? Can you just quickly roll out? Because it is easy that B and D can be easily ruled out.
So infimum may be 0.
Exactly. Just take infimum equal to 0. That's all. So just take, say f is a function from 0 to say 1, and say f(x) equal to x. That's all. In that case, if you take any partition, then that part you will have some positive part in the left side, but the right side that will be 0. This and this. So this term can be easily ruled out. Now what about E? Is it true? So instead of,
false.
so I have just replaced that A by E, and I just remove the mod sign. Now can you see that why E is false?
So maybe if belongs to the negative part and supremum maybe it's 0.
Exactly. Good. In that case, you will have some non-negative value here, and if you have some f which is some say -1 to 1, then supremum will be 0. Say sorry, -1 to 0. Say the function, right? Okay. So this is also can be easily ruled out. Just a trick. Okay, good. Next we move to the next problem. This one. Now say what will be the possible choices. Again it is almost similar to the previous one. It is almost similar to the previous one. it is also a continuously differentiable function, and f dash x is less than equal to k, right, and you need to find this. So, first of all, since the left hand side is more or less about only UFP minus LFP, just we calculate first. So, UFP minus LFP. So, we first just calculate. So, what is that? Okay. Now, that will be summation, that one summation I equal to 1 to m capital M I minus small m I x I minus x I minus 1, this one. Again we can, what we can do? So, instead of this we can replace it is norm p. So, we can write this is less than equal to norm p summation I equal to 1 to n m I minus m I. Now, again it can be f of x I dash some number, it can be f of x I double dash some number, right. Now, we have seen that it is less than equal to norm of p. By applying that mean value theorem, we have I equal to 1 to n mod of f dash some x I star, right, mod of x I dash minus x I double dash. Again we know that this part is less than equal to x I minus x I minus 1, therefore, we can again have this p, and it is given that is less than equal to k, we can write here k. So, summation I equal to 1 to n x I minus x I minus 1. So, therefore, it is norm p k b minus 1. So, we get that d, right. Now, what about b and c? So, first of all look at b and c. Now, if we remove that b minus a, then can it be, is it true, or if we remove that norm of p, then is it true? Now, obviously, by the guess that it looks like b and c will not be true, right, because in the right side b minus a can be larger, right. Okay. Now, can you just now quickly tell me what about a, b, c, are they true or not? Just give me examples for a, b and c. So, for a, what is given? See, first of all, if you look at a, then it is given that LFP less than equal to k times b minus a. Okay. Now, for this you have to remember that f x equal to x is a good choice always. So, first of all, for a we can just take f x equal to x. Now, since we need to find that UFP, so we actually will try to find that UFP is a lower number. Now, then we can take my interval is minus 1 comma 1, okay, and we can take the partition p equal to minus 1 0 comma 1, because we want to make that UPF is smaller. Then what will be my UPF? That will be, what is the maximum value between minus 1 and 0? That is 0, and norm is 1 plus, right, and what is the value, maximum value between 0 and 1? That is 1, and the distance is 1. So, therefore, UPF is 1, right, and here f dash x equal to 1, therefore, you can choose k equal to 1. Now, what is my k into b minus a? So, that is 2. So, k b minus a, that is 2, and UPF is 1. So, therefore, this is not true. So, we can rule out this. Okay. Now for the B, what we can take, see, it is that UPF, right. So, what we will try here, we will try to make LPF, that is 0, and this is a large number. So, that is what we want to take. So, for B we can again take f x equal to just x, we can take the interval 0 2, okay, and we just choose P by 0 2, that is the single partition. Therefore, LFP, that will be 0 because the infimum is 0, and UFP we need to make this is bigger, right. Now, that is 2 into 2, that is 4. So, therefore, UPF minus UFP minus LFP is 4, but what is my k into B minus A? So, that is 1 into 2, that is 2. So, you can easily make that is not true. And for the T, for the C, now see, remember that here it is given, it is k into norm P, right. Now, what is our trick? Now, we will make that norm P smaller, so that the right side will be smaller. Now, again we can take similar example. So, f x equal to x, we deal with 0 2, but this time we choose P equal to 0 1 2. Just take an extra number as a partition, so that norm P will be smaller. Now, you can check that what is my LP. Now, LFP, that will be 0 into 1 plus 1 into 1, that is 1. UFP, that will be 1 into 1 plus between 1 and 2 the maximum value is 2. So, it is 3, right. So, UFP minus LFP, that is 3 minus 1, that is 2, but norm P, this is also 1, k is also 1, that is 1 into 1, that is 1. So, we are done. So, that means this is also not true. Okay, fine. Say yes, so that I can move to the next problem.
Yes, sir.
So for C, we can use the same example as B.
I think it will work, maybe, I do not know. Is it working there? You can check it, if it is work, then it is fine. So, I thought here, since we have left side norm P, so I thought we should make norm P smaller. So, I have taken that example, maybe that will work which you are saying. I did not check. Okay. So, my just here idea is, since right hand side we have to give a counter example. So, we can just make that norm P smaller, that is all. So, that was my idea. So, I just take one extra point. So, when you solve a problem, you should have used this kind of trick.
Okay, sir.
Okay. Now, this is the next one. Now, it is given that f, g, h are bounded functions such that f less than equal to g less than equal to h and p is a partition. Now, these are the options. What should be necessarily true? Again, if you just go through the our definition of UFP and LFP, then you can easily see that LFP less than equal to LGP less than equal to LHP. Okay? And similarly, you can find UFP less than equal to UGP less than equal to UHP. Right? Now, this one gives minus L HP less than equal to minus L GP less than equal to minus L FP. Now, if you add this with this, then you just get UFP minus LHP less than equal to UGP minus LGP less than equal to UHP minus L FP. So this one. Now from this you can easily check that. Now if this is less than 1, so if this is less than 1, then obviously middle part will be less than 1. So that will be a one right answer. Now what about the other A, B and D? Now D looks like impossible because it says that, see, this part is less than or equal to 1, right? No, which part it is? U F V, right, it is something of negation of that one, right? D. Okay, anyway, so now can you give a counter example to show that other one is not true? Because if you look closely, then if there is a relation between upper limit and upper sum and upper sum, then how do you get a relation between upper sum and lower sum? And similarly, if you get a relation between lower sum and lower sum, then there is no meaning, that is right, to get a relation between upper and lower. And similarly for D. Now this is just the left side of our equation, that minus of that one.
Sir,
Yeah.
the last one D. First UFP minus LHP, it's can be said that greater than 1.
Greater than 1 or not greater than minus 1, right? Something. Because you are multiplying with minus sign.
Minus 1.
So it is greater than minus 1, but you cannot say that it is less than 1.
Yes.
Right. Now there is a simple trick. So this is, as I told you, na, so whenever you have this kind of problem, your fx equal to x is always helpful. So you have to remember that always fx equal to x. That is a simple example. Now here also it will work. Now just take, it is given that f less than equal to g less than equal to h, right? Now just take, all are the same functions. So let f equal to g equal to h, all are same, and this is just x, that identical function, and choose that closed interval 0 2, and choose p equal to 0 2. Why we are choosing p equal to 0 2? Because I just want to avoid that lower sum, that is lower sum, right. So I just want to avoid that lower sum, because in that case lower sum will be always 0, right, because we have a single partition. Now you can calculate that. In this case, u gp minus l gp, that is, here we have 2 into 2 minus 0, so that is 4. Okay. Okay, I am missing something. Okay, no, fine, it is 4, but what is the left side? Since both are same, right, so therefore that is 0. Clear? Since f and h are the same function, I have chosen, so that is 0. So left side is 0, so less than 1, but in the right side we get 4, right? And similarly here also left side is 0, so less than 1, so right side here I get again 4, right? And this is, if you calculate this one, so L H P minus U F P, that is 0 minus 4, then again it is minus 1, but the right side is greater than 4, greater than 1, because that is 4. Clear? The example, this simple one. Okay, can I move forward? Okay, good. Now there is the next one. So let f be a continuous function with period p and gx equal to this, and what are the possibility? Now, this is a simple one. Can you quickly guess the answer of this? That is actually very easy. First, this is very easy. So, first of all, we can write this is, suppose you have d dx of, say, integration phi x psi x, say, f of x t dt. Now, the formula is, you can easily also compute that formula, f of x psi x into psi dash x minus f of x phi x phi dash x plus, now integration that phi x psi x, and that will be del x of f of x t dt. So, this one. Now, if you use this formula here, you will get g dash x equal to f of x plus p into 1, right, minus f of just x into 1 plus integration x plus p into 0. So, you get just f of x plus p minus f of x, and it is given that f is a continuous function with period p. So, therefore, that is 0, and it is true for all x. Now, since g dash x is 0 for all x, therefore, g should be constant function. So, this. Now, we know that every constant function is continuous, right. So, this is also continuous. Now, again we know that any constant function is also differentiable as well. So, therefore, this will not be the right answer and this will not be the right answer as well, right. So, we are done. This is a simple one.